Okay, now I will just go with the normal snap node beam, and then so okay, something I'm having a structure like this. I will just go for a translational repeat. Okay,
Okay.
so go for Z axis, and then I will just have only two, and then in between also I will have five link steps open ways. Okay, this is what the structure looks like. Okay.
Okay.
Mm. So you can also consider some plans. So you can have some plan. So based on the plan, you can just make this kind of structure. But you're supposed to change this to XZ grid so that you can able to do, and then you can just translational repeat and delete the base one. That is
Okay.
also possible. Okay. Now what I will do means like immediately in the page control, similar what we did to the beam, you need to go here. So go to the support and create fixed support. Always fixed support for the structures. Okay. So that
Okay.
we can able to go for foundation design.
Okay.
So select the support and then go to the here, select the nodes and then assign to selected nodes. So now you can able to ensure that in the isometric view. So it should be like this. Wherever the columns come in, you should have a footing over there.
Yeah. Okay.
Okay. Then we can just go for so property and then define. So here in the rectangle, so these are all the things we already discussed, right? Now what I will do means like I will try to create a separate cross section for beams and also for the column. Okay. So you can see the
Okay.
picture for okay, and also concrete material add again. So I will also consider a column. Okay. So two things we created, and also I will go for a this is for a steel section. So I just want to have thickness for plates. Okay. So this is we don't need now. We can discuss it later. Okay. So I want thickness for thickness of plate. I will consider a 0.2 meter. Okay.
Okay.
Okay. This you can also edit after if you don't want. Okay. But for we are having beams, but for plate, what you can do means you have a plate cursor over here. You can select the plates, but to create the plates, you need to go to geometry and you can just go for add plate. You can create quad plate method and triangle method.
Okay.
So the quad plate means like you can just select the four nodes. So this is auto save option. Geometry and then add plate, quad plate. Okay. So
Hmm.
1, 2, and then 3, and then 4. Okay, this is for quad plate. You can able to see in the 3D view. Escape, and then go for 3D view. See, it is coming, the plate.
Okay.
Hmm. See, you can able to see, right?
Yes.
Yeah, you should escape completely, then only it will come. You should not have any conditions over there. Okay,
Okay.
but you can also go for geometry and then go for triangle. So triangle in the sense only three nodes it can able to connect.
Okay.
So escape and then see. So this is
Mm-hmm.
the method. So whenever you want, you can able to create it like this. But now what I will do means like I will select both control and then delete. So to select it together, right? Control you need to hold. Okay. And again, if you want to like remove one shift, again also control you can use it.
Okay.
So control, if you want to unselect in between also, you can use control. Okay.
Okay.
Uh, then what else like, yeah, there is one option. What you can do is like go here just to select only these portions.
Mm-hmm.
Mm. And then go to geometry, create infill plates. It will automatically create the plate, but you will get the quad plates. That is what we need actually. See, 16 plates were created. So
Okay.
this is,
Can you show that? Yeah. First thing again, like how to select?
you need to go to the view like this. So it's easy, right? So you can select the only the beams. Okay.
Okay.
Hold the control. I was telling. Then you can just go to the isometric and then right click also you can go right click and then create infill plates. But sometimes if it's not coming, don't worry. So you can just go to geometry and create infill plates
Okay.
because we already created, right? That's why it's not coming in the right click.
Okay.
So you can see that.
Okay. Settle.
Okay. So that so these things you are okay, right? Now you can just go for but we need to assign, right? We just created, but we not assigning the property. So without assigning, you will get lots of error. So what I can do is we have plate, right? Plate we can go for assign to view because all plates going to have a same thickness. So after you can see the assignment. So the plate thickness coming. Okay. So that you can
Okay.
see in the 3D view. This is how the plate with the thickness. Okay. So we must have plates for element design, a slab design, okay, in concrete. So then we can just go for a point three. This is for column. So what we can do is there is one easy selection. Go to select menu and then go to beams parallel to which Y.
Why? Okay.
Yeah. So that it will select only the Y and then members over there, and then you can assign to the selected beam. So you can see the R2 it will come. Then again you can select the top one. Now what you need to do, beam parallel to x-axis and also without escaping to z-axis so that we can select the both axis beam. Now you can assign to the selected beam. Now as a whole you can see the 3D render. Okay.
Okay.
And we also see the member offset right before.
Sorry, offsetting. Yeah.
Member offsetting. Yeah. But that one not needed anyway for big structures. No need to like do that one for everything. We can just continue with okay, no problem. Then what is like we done everything so that we can go for loads and definition. So this is what the procedure. Okay, so you can follow the same. So go for loads and definition, and we have definitions here, right? So these things we can discuss later. But now,
Mm-hmm.
as a simple analysis, we can go for a dead load and live load. Okay, so the dead load and then live load. So dead load. So self weight in y direction. It is going to act in the ground. Okay. So self weight and then assign to view so that it is having question mark, right?
Mm.
Hmm. And I will just go for assign to view and then S. Okay. So now you can go for live load and then add.
Mm.
So here we can able to like have multiple loads. So nodal loads or member loads or like that. So nodal load in the sense we have we can able to like create only the loads acting in the node. Okay, we can apply only to the nodes and also support displacement to the supports over here. Okay,
Hmm.
but for this structure, these things not needed. And I will go for member load. In the member load, we have a uniform force. So you
Hmm.
are going to have construct bricks on top of the beam. Okay. In that case, like you can just consider the self weight of the brick or unit weight of the brick, and then you can come to a value. So that value you can put as a uniform distributed load.
Okay.
Okay, so mostly like if it is like inner walls, like you can have 11.5 kilonewton per meter square, or if it
Hmm.
is like outer, like 19 kilonewton per meter square, like that, you can able to consider. It depends on different bricks. Okay,
Okay.
okay.
Instrument force.
So that you can put, but how you can put like a uniform force, like I will just put minus 19 kilonewton per meter. Okay, kilonewton per meter. Yeah, it is the distribution over the length, right? Okay. And then you're
Then
supposed to put minus in the global y, because in the global y it is going to act in the downward. Okay, so add it. So then also this one we will assign and then we can come back. I will just
okay.
select it and then the same selection, how you can go select. Okay, by specification, like this different kinds of selections also we can do.
Hmm.
Okay, beams means it will select whole. This is difficult actually. That's why you can just go to select beam parallel to X, parallel to Z. Always you can use this one.
Okay.
And then assign to selected beams. You can see like this the brick load going to happen. But I am just putting only one value, but you should have many such loads and you can put for the inner walls and also in the terrace, no need. Maybe for only less value you can put like that.
Okay.
But now for the analysis, like I'm just putting to the all beams. Okay. Okay. Then I will try to change the floor load. Okay. I will try to create a floor load. Okay. So add, then I will just go for floor load. See, when you're considering floor load, we can also go for area load, floor load, and plate load. Since we are having plate load, plates, we can also go for plate load. If you don't have plate load is not possible.
Okay.
So I will go for floor load. So anyway, with the floor load, we can able to get the element design anyway. So for floor load, plates is not necessary, but for element design in concrete, you need to have plates. Okay. I
Hmm.
will go for by default some kinds like you can refer the code books and you can come to your own calculation and value. But mostly we will
Okay.
consider minus 3.5 kilonewton per meter square for a floor load.
Okay.
Okay, this is for floor now. This is as area. That's why kilonewton per meter square. It is like a pressure.
Okay.
And in
My,
y direction minus. Okay, global y. And also there is one-way distribution and two-way distribution for slabs, right? If it is like
yes.
length divided by breadth, less than two or more than two, like that we
More,
have, right?
yes. Yes.
So mostly this is like a small rooms or small area. Then we can go for
Hmm.
two-way distribution. No need to select one way.
Okay.
Okay. So that you can calculate and you can come to conclusion which distribution you want. Now you can
Hmm.
just select, there is one method. So just to go here, here you need to just put the ranges, right? You just
Hmm.
put node cursor and then double click it. So this you can consider as a minimum. So 040. So why it will
Hmm.
come. So this 4 you can put. Then on top portion diagonally opposite you need to select. So this is like a 6 10 10. But I don't want I want some other load here means like you need to select only here. So below. You
Okay.
understood, right? Now I will consider as a whole structure the same load, okay? And
Okay.
then 10, 10, 6, 10. So you can just put 10 and then 6 and then 10 and add it. Now you can see how the floor load is coming. See, actually, can you able to see the mistake? when we are applying, we are just considering only from here, but we should also consider this one, this portion.
Yeah, so the top diagonal should be selected, right?
But no, even after you can change it. Now this portion you should select 10, 7, 10. So maximum in these things you should also put there. So so 10, 7, 10. So 7, 10, 10. Uh, so this one 10, uh, and also Z10 and X also you should put 10. Yeah. So when you're putting X also 10, then when you're changing, then you can able to see everywhere the floor load is getting.
Okay.
Okay.
Another method. We selected it from where? Like,
You mean like node cursor and you can just double click the node.
no, no, the option. Okay, okay. But we just from where we took that option, like another method.
No, the floor loader you are asking, right?
Yeah, floor load. Then
See,
you were
live load, you need to select the live load and you need to go for add and then you need to just go adding the floor load first. And
floor
here
load.
you need to put,
Ah, okay, okay, okay. Understood, understood. Range.
yeah,
Mm, okay.
okay.
Yeah.
Hmm. So I think for this structure, so this load sits enough so that we can go for combination. So just to select the load case detail, add. So then you are getting defined combination, right? You can define your own combination. For example, if I'm putting 1.25 and then if I'm adding, so when you're adding, you can see 1.25 times the dead load and 1.25 times the live load it will take. Okay, like this, you can keep on adding your own load combination. And also you can go for auto load combination as per the code book. So if I'm just considering the ACI, so you're also having British and all, Indian code as well. So as per ACI code and also as per the table one, you can consider the referring the code books. So a
Mm.
specific code book for the details if you want to study even more elaborately. Then you can generate load and it will automatically generate. So if you want to consider the repeat load cases, you can consider. Otherwise, only these loads it's enough.
Okay.
So it will come. So even these things, we will try to modify when you are going for this. So we can't
Mm.
able to edit. So there is no edit option. Everywhere you need to do there itself. Okay, if you want to edit something. Okay. So when you click here, you can get the edit option. So
Mm.
again here, yeah, you can edit from here as well. Yeah. So but you should not select this one. You should select the
Oh,
what? Yeah. So you can just change now these values if you want 1.25 or one or something like that. So later, this is 1.4, right? But you can just edit also. Hmm.
okay.
Okay. Okay. This is like defining the like what we can say, like we are just creating the loads and also assigning the loads. Okay. After assignments and also we are creating a combination of loads, user
Mm.
defined combination or as per the code
Yeah,
automatic
chorus.
load generations. Okay. So as usual, like analysis and print, only one, and then enough, and then now you can go for Control F5 or analyze this option. So wait for a few seconds. Since it is like very small structure, it will come immediately. So you don't have an error or, but one warning, it might be because of the one way, two way for the slab. Okay.
Okay.
So I'm just going to the output file, and then you can see this is like that you can consider maybe inside some of the slabs you can put two way also based on the value, right? So the longer width divided by the shorter width, it should come less than or equal to more than two, so that you can go for two way or one way.
Okay. Okay.
Yeah. So this is coming plate load, reaction load, and all. Like this is what it is. Now we can go to post processing, and in the post processing, you can select all also, and you can select only one combination. Anyway, these things no need to do anything, and then click OK. So you can see the post processing for nodes and beams and all. So displacement it will come, and reactions. So you can see the reactions,
Mm-hmm.
okay, in the Tableau column, and also here in the, see, for example, this option you can use if you want to see even more. Yeah,
Clear. Okay.
yeah. And then the reactions and then displacement. So displacement, you can just hold control and then scroll to see how it is. Now even you can go for animation. So animation, no animation, but now see, you can see like this. This only for
Okay.
viewing sectional
Animation.
displacement also you can able to see like this. Okay, okay. So when you put escape, it will stop. Then you can go for beam, and the beam you can see right the bending moments, and you can switch it off, and shear forces, and you can also see the value right from here.
Results. Okay.
Yeah, and also the axial forces. Axial forces you can just hold control and then reduce the size. So normally axial force it will be more in the ground floor columns, and it will be less in the top floor columns, right?
Okay. Yeah.
Yeah, this is common, and you can see the displacement and all. Okay. So you can see the values and all. And you when you see when you're selecting, even it will be highlighting somewhere here. When you're selecting, it will be highlighting. So it is like if you're selecting this, so for example, if I'm selecting this one, it is automatically. So it is like everywhere, it is linked together.
Component. Okay.
Okay. It is similar to the BIM software where everything is linked together, right? Whatever you are doing, it will be applicable on all windows, so similar to that.
Okay.
Then we have stressors also. In the stress,
Hmm.
like you can just select the particular column or beam and you can see the value of stress value here, right?
In that particular one, right?
Yeah, you can also change the distances and you can able to see the stress value. Again, here you can go for display legend and also display corner stresses. So like this, you can able to study the beams and columns. Okay. So if I'm selecting column again for the column also, you can see the corner stresses and also the overall stress as well. Okay, the legend here. Okay, the values also here it is also available. You can able to see the maximum stresses and all.
Okay.
Okay. Then in the graph also you can able to see for beams and columns.
Okay. Like bending moment and shear force, right?
Yeah.
Actions.
See, Fx means like shear forces. Mx, Mz means bending moments.
Okay.
Yeah. So separately you can able to see the values and all, right? Mm. So then now you can just go for a plate. So we are also having plate, right? So for the
Hmm.
plate, we can also see the these things, maximum absolute and all. See, you can see the legend also coming.
Okay.
So where the maximum stress is there. So somewhere here.
Okay. From where you selected plate, right?
Ah,
That dialog.
from here the this
Okay.
one.
Good. Yeah. Okay.
So again, you can also study different things here, mostly maximum absolute and also this kind of thing. These
Hmm.
things they used to study. Even this you can able to modify your own values also. See, absolute values, use custom limits, then you can put your own limits also.
Okay.
Okay, accordingly the legends it will be split up. Okay, so you can analyze the plate. Okay, where the pressure is more, like that you can able to analyze. Okay, okay. And this is what it is, the post processing. Okay. Then that's it. So you know, write everything now. Then we can just go back to the modeling. Now everything we are getting perfect. Now at this stage we can go for a design. So concrete design.
Okay.
So from here, the page control design we have, we also have a concrete design separate. But this one, it will go to the a plugin or like separate software. So linked with the STAAD Pro. So
Okay.
this is like a different method. This is like a different method. So you need to do now this method only. So go to design
Okay.
and here you can able to see steel design, concrete design, timber design, aluminum shear wall design. Okay.
Okay.
Now you can just go
Decide.
to concrete design.
Okay.
So in the concrete design, now you can just select which code book you want. By default, it is coming ACI code. I will continue with the
Mm.
ACI code itself so that you can able to like design all beams, columns, and slab. But sometimes in Indian codes, and you know, you can't able to get the details for slab. So I will continue with the ACI code, and you need to go for select parameter. So mostly, like not everyone will select all parameters. Then you need to like assign all the values, right? Now for this purpose, I will consider only the compressive strength and also the main and secondary strength. So this is for a concrete and this two for a steel. But you should, for a real-time project, you should consider even more parameters. Okay.
Yeah. Okay.
So you can just go to define parameter. So only three it will come. So for our purpose, like learning purpose, I'm just selecting three. Otherwise, you will need to select. You need to put all, right.
Yeah.
So in the
Yep.
parameters, if you're having some doubt, you can refer the code book, particular code book. Then you will be like getting some idea of what value you should put or how you should put. So this is like compressive strength of concrete. So I will consider 25 M25 grade of concrete, right?
M20. Okay.
And then you should not put M20, M25, something like that. M30 you can put like that. Okay,
Okay.
for F, and then for FY main, why it is coming by default, it will come like this. But you need to change to the round of value. We have 415 still great. No, otherwise you will get a warning. That's why I'm
Oh.
changing. Even in the output, it is not looking good if you are not changing this. So this is what the M25 and 415 grade, right? So then I will go for assign to view because all members going to have concrete and also reinforcements inside. So I'm not going to consider separate thing. Assign to view is better. You understood now what I mean?
Yes. Ascend.
You got right. Which means
Yes.
like this is like whole RC structure, so that you should assign both concrete and reinforcement parameters assign to view. Okay.
Yeah.
Now what I will do means like I will just go to select only beam parallel to y-axis. I selected only column. Now I will go for commands. In the command, I'm going to design column. So since I selected already, we can directly assign. So that question mark it won't come. We don't need to assign again. So you can able to see like close and see it is already assigned. See? Okay.
Okay.
Now what we can do means there is something called the select inverse selection, inverse beam selection. So that it will try to inverse the selection. Okay.
Okay.
Now you can go to command. Now I will go for design beam and assign. So directly we can able to assign. So when you are just selecting, it will be highlighting also. Okay. Now I will just select the plate cursor and I will select all the plate commands. So define slab or element assign. Okay. Then for the so since you need to escape, right? If it is going like this, don't worry. Again, you can just select concrete. It will come. So and you can remove the button. So it will be selected. And again, if you want to see the quantity, so the how much concrete in cubic feet or a meter cube, and how much reinforcement in tons or LBS. It might be because ACI code, na, it will come in LBS. Okay. I
Okay.
will go
Okay.
for commands. So I will go for takeoff. No need to assign. Like so, go to concrete. So the commands takeoff. See takeoff just to add only. No need to assign. So it will consider as a whole. So concrete takeoff. Okay. Like when we are going for analysis print, like that, if you're not putting, it won't show in the output. Okay.
Okay. So
Now
you
you
have
need
to
to,
select.
yeah. Now you need to go for analyze, run analysis, and save. So again, if you're not analyzing, you can't able to see. Actually, I will forget to show you another one also. See,
Hmm?
anyway, now here the result you can able to see the concrete design also. It will come. Before it was not there, right?
Yeah.
So you can see for each and every columns and all, you can see 8 number of 12 bar, and also like spacing, the tie bar numbers and all, even the area of steel required, and see here the values of concrete and reinforcements and all. Now you can go for Control F, and you can also go for beam. See, you can
Okay.
see the beam. Uh, so increase member size. See, member fails in actually beam member fails, so that it is not displaying the value. So what it
Okay.
is asking means, like based on our inputs, now we are also putting huge brick loads, so that it is
Hmm.
asking to increase the member size.
Oh, okay. That
So that
also
after
matters.
member size, you can able to get the values over here. But what about the slab elements you need to put?
Hmm?
Maybe for the element also it is not coming because already beam failed, right?
Yes. So
So now we can go for takeoff, but it is showing the takeoff. See, all number sizes it is showing, and also how
hmm.
much the concrete in cubic feet. But member fails, so you can just see the which member fails. So you can go select by specification all failed beams. No, if it is not, see, it is only for steel or aluminium. Mm,
not for concrete. Okay.
not for concrete. So what we can do is all beams, so that no need to worry. Just go to geometry or general. So here I will just try to change the size. So I will try to change this 2.45 also. But so that the post processing result it will be changed. It will be telling how it is looking in the 3D rendering. Now it might accept. Okay.
Okay.
So view to
See.
output file. Hmm. So now it might come. Good result. Control F beam. Member fails in maximum reinforcement. Increase member size. Even more increase member size.
Okay.
3.5 kilonewton, 19 kilonewton per meter. Might be like a brick load we are considering too much. Anyway, like I will just go back and then try to change the. No, even you can reduce the load or you can able to increase the size. Both also we can able to do. Anyway, I will try to edit this one. Maybe I will just put 12 kilonewton per meter
Okay.
because not this much load, not for the internal walls also. That's why I mean like only the outer walls it could be better. Now I will just go for analyze. See, now you can able to see beam we are getting 6 number of 25 bar.
Okay.
Yeah. See, now you can also see the values over here. See, also
Hmm.
10 bar 12 center to center, 10 number of 12 bar center to center 181 like that. Okay. See, these are all the things we can able to note now. Now as a whole also take off. So if it is The meeting end means like you can continue, okay, immediately.
Okay.
Yeah. So as a whole, you can see the quantity, so you can go for procurement accordingly. Okay.
Okay. Bar
And
size.
yeah.
Hmm.
Now, when you're just double clicking it, then you are getting concrete design. Before this, it won't be available only until deflection. This is what I forget to show you. Now the concrete design also coming. So what you are seeing in the output here also pictorial representation. You can see all this value. Yeah. So now you can able to see all these things, right? And also you can just double click the column. So for the column, it is different. For different column, you can also select and you can see how it is. See here, it is different. See here, it is like 4 number 40 mm bar, but in
Hmm.
the below, it is
Below.
just
Okay.
showing like 8 number of 12 mm bar.
Bars. Hmm.
So accordingly, you can consider the same, or you can also accordingly reduce the bar numbers and increase the bar sizes.
Okay.
But you can refer the area of steel required, so that accordingly you can plan.
Okay.
So that's it.
We have
This
to
is
add that concrete design there. Then only we will be able to see it here, right?
otherwise this tab it won't be visible.
Yeah. Okay. Okay.
We already discussed all this, na? You
Yeah.
remember?
Different loading. Yes. Can you take the loading again? Like. Oh,
Loading here. Ah,
yeah. Nothing was there.
this is
Yeah.
for dead load and live load. And what are all the cases you are? This no need to worry. Don't confuse. This is just what you are putting here. It will come.
Okay. Okay.
So yeah, here add new load item. Remove. No one will use all these things anyway. Only these things they can able to refer.
Okay. Shear deflection. Hmm.
Yeah. Only to see the value for the dead load, the deflection. It is in the x direction or also y direction. So user directions like that you can able to see for dead load itself. But for live load, you can also see the values. And for different, you can see here the value at 3.07.1 mm displacement like that.
Okay.
So, so now you understood now how to analyze the 3D RC structure and also how
Yes.
to design concrete.
Yes.
Okay, so that you can just consider creating some plan. So you also try creating geometry, circular beams and all. You just
Okay.
refer some. You do you have any AutoCAD plans with you so that you can just do the same here and you can
Okay.
just do analysis and concrete design what we discussed today
Okay. Okay.
so that you will
Let
get
me.
some confident.
Okay.
Yeah.
Let me check if something is there. I don't think, but I will refer like online or something to get a plan.
Online, yeah, online you can refer, but if you want, like I can give you one image because I have one
Yeah.
book.
Okay. Okay. Then it's sure. Like you can share that with me.
Okay, so that you can able to try because in that book
Yeah.
there are more plans or everything. Okay.
Okay. Okay.
So, do you want to discuss anything else? Do you have any doubt or something?
Not now. Like after practicing, I will get back. Like if anything is there.
Yeah.
Okay.
Then okay, then we can able to close the session.
Okay. Yeah. Then it's fine. Okay. So tomorrow the same time we can meet.
Yeah. Okay. No problem.
Okay. Yeah. Okay.
Thank you. Bye.
Okay. Thank you. Yeah. You have my mail ID like for sharing.
No, no. I just take a WhatsApp pic and I will give
Oh,
you
okay,
directly
okay,
on
then
mail.
it's fine. Okay, okay, then it's fine. Okay, okay, thank you.
Okay. Bye.